Hi. Today, I'll be using Euler's method to approximate the solution of a differential equation known as initial value problem IVP. Let's understand how Euler's method works. Let's say we have a curve, which is the exact solution to a differential equation. However, we don't know the full curve. Only the rate of change dy over dx and the starting point are known to us. So let's start from the starting point x0, y0. Here, from this starting point, we draw a tangent line which comes from the differential equation. Then, using this slope, we take a small step along the tangent line to estimate the next point x0 plus 1, y0 plus 1. How do we estimate the next point x0 plus 1, y0 plus 1? When we take one step at x, which moves forward by h, which is the step size, we adjust the y value using the slope. This formula shows how Euler's method estimates the next y value by moving from the current y value, y0. F of x0, y0 is the function from the differential equation. This tangent is like a straight line approximation of the curve at that point x0, y0. In straight lines, we use the idea that the change in y equals the slope times f of x0, y0 times h. This gives the estimation of an actual curve. To find the gradient of the slope, we use the rise over run formula. This is the rise y0 plus 1 minus y0, and this is the run x0 plus 1 minus x0. The run x0 plus 1 minus x0 is equal to the step size h. By rearranging the value, we got the Euler's formula, which is y0 plus 1 equals y0 plus h times f of x0, y0. Using this Excel spreadsheet, let's solve this problem. We want to estimate what y value would be when x is equals to 1. Let's assume our step size h is 0.1, so we need to do 10 steps to get to x0 equals to 1. This column shows the number of steps from 0 to 10. This column shows the value of x0, which is increased by 0.1 each step until we get 1. This column shows the values of y0, which is the Euler's estimation for the curve. We calculate the values of y0 using this formula. Y0 plus 1 equals to y0 plus h times f of x0, y0, where f of x0, y0 is equals to x0 square plus 1 over y0. This column shows to calculate the slope at each step by using the differential equation. This column shows to calculate the next y value by using the Euler's method, where the y0 value from here is added to the h times f of x0, y0. So here, we are using the current x and y values to get the slope at each step. Then apply Euler's formula to find the next x and y. When x is equals to 1, our approximation for y is 1.91138. This is our final approximation for y when x is equals to 1. Let's calculate the accurate value of the differential equation. First, we rearrange it to get this equation. Then, we integrate both sides. We do the integration and we get the value of y, which is equals to this. By using the initial condition y bracket 0 bracket is equals to 1, we can get the value of c, which is equals to 1. So then now, we need to calculate the value of y when x is equals to 1, and then our final answer is 1.914854. We have to reject minus 1.914854 because y has to be greater than 0. The error is the difference between the Euler's approximation and the accurate value, which is minus 0.003474216. This is the end of my presentation. Thank you.